Guys，这一个视频呢，它并不是平常的那种什么 real 自救日记什么的。呃，因为之前有个想法，就是说要记录自己学习的情况，就是 it's a way to help，嗯，怎么说呢？It's a way to help myself to 嗯 be consistent，嗯，in terms of self-learning, maybe yeah. And I'm going to talk in whatever language that I'm comfortable with in this kind of video. So it can be Cantonese, English, or Mandarin, whichever one I feel like to speak with. So yeah, just don't mind me if switch the language in a sentence. Um, um, okay. Yeah, so it's like 11:15 already at night. And I thought it's good to, learn something before I sleep. Okay. I think this will last mm, around 1 hour at max. Mm, oh, fuck. Ah, yeah, my body's in pain because lacking of sleep. 就最近有点失眠，4点多才睡着那种。啊，fuck. Maybe I should consider taking some sleeping pills or something. Maybe. Okay. So there are two things that I would like to check out tonight. So one is let me show my screen. Um, yeah. Oh, whenever I share my screen, I don't see my 头像. How do I see myself? Hmm. Hmm. No, I really don't. I really want to look at myself when when I talk. No, sometimes it feels like you're talking to yourself. I don't like it when there's no audience. Oh, fuck it. Just go. Okay. Yeah, after work tonight, I was chatting with my friend, right? And somehow we were talking about Swarm and IPFS. I have no idea what they are. So let's let's do some research and see if we can understand, right? And we can actually make it more efficient. So we can, all right, we'll look at Chinese explanation, and then we can have a look at the English version. It helps me to understand it better. In case if you don't know, I'm not very good at English. I'm not a native speaker. But stuff like this, like, if you don't have the Chinese education background, it's hard for someone to understand these concepts in Chinese. So yeah, I'm gonna read both. And the reason why it's hard to understand in Chinese is because the terms that they use, right? The terminologies, you're not familiar with those terminologies. Okay. Okay. Mhm. Mm. Damn, there's a lot going on. Fuck. Okay, so they are both peer-to-peer, and so data sharing network in which files are addressed by the hash of their content. Okay, and they're both decentralized. Um, okay, so it's a file transfer system which is decentralized, and it works on peer-to-peer. Okay, and data sharing network in which files are addressed by the hash of their content. And it can be used to store HTML, CSS, and JavaScript that implement an application on top of other decentralized systems. It can be used to store static files. Some imply that Swarm may be better for small chunks and low latency. So BitTorrent is good at delivering large chunks of data with high throughput and high latency. Swarm is also good at delivering small chunks of data. Why do you say? Why do you say also? It's not also low latency, which is necessary for some anticipated application. Some building incentive. Building incentive. Some feel that Swarm is preventing the group. Should just be used instead. Makes sense. Platform is being incentive. I hear this peer-to-peer distributed file system that seeks to connect all computing devices with the same system of files. Okay. In some ways, IPFS is similar to the web. Mm-hmm. Okay. Not understanding the whole concept, but yeah, I do have a vague idea what they are. The fuck? Which tip is obsolete? I need to watch a video. Come on. Not fucking loading. Not fucking loading.
In this lesson, we'll learn about decentralized storage and some services that are available today like IPFS and Swarm. You can think of decentralized storage as a peer-to-peer network where members pool together their disk space to create a shared global memory, kind of like
He's too
Dropbox, but
close to the
decentralized.
camera. Oh God.
Both IPFS and Swarm are similar in that they are open source, decentralized storage solutions, but they differ in implementation and approach. IPFS, which stands for Interplanetary File System, is a protocol that was published by an organization called Protocol Labs. The first implementation of the IPFS protocol was written in the Go language and published in early 2015. And today there are several alpha release implementations available, including in JavaScript. Swarm is also a protocol and is part of the Ethereum holy trinity that makes up the serverless world computer, which consists of Swarm, Ethereum, and Whisper. These three infrastructure projects are part of a broader vision that provides a completely decentralized alternative. Today, there are several alpha release implementations available, including in JavaScript. Swarm is also today there are several alpha release Go language and published in all labs. The first implementation of the IPFS protocol was written in the Go language and published in early 2015. And today there are several alpha release implementations. System is a protocol that was published by an organization called Protocol Labs. The first implementation of, but they differ in implementation and approach. Both IPFS and Swarm are similar in that they are open source, decentralized storage solutions, but they differ in implementation and approach. IPFS, which stands for Interplanetary File System, is a protocol that was published by an organization called Protocol Labs. The first implementation of the IPFS protocol was written in the Go language and published in early 2015. And today there are several alpha release implementations available, including in JavaScript. Swarm is also a protocol and is part of the Ethereum holy trinity that makes up the serverless world computer, which consists of Swarm, Ethereum, and Whisper. These three infrastructure projects are part of a broader vision that provides a completely decentralized alternative to the currently centralized web. Ethereum would provide the computation power, Swarm would provide the storage layer, and Whisper would provide a messaging layer. Swarm and Whisper are not quite as far along in their roadmaps as Ethereum itself, but a proof of concept Swarm implementation written in the Go language is included as part of the Geth client since version 1.5. You may have noticed I said that both projects are either in alpha or proof of concept stages, meaning they're not quite yet ready for the production spotlight. But understanding the role of decentralized storage in the future web is important, so you should know how to make use of these tools. As these projects evolve and mature, they will become increasingly production ready. Let's start by looking at how to use Swarm. Since Swarm is already part of the Ethereum stack, a proof of concept Go language implementation exists as part of Geth. So to activate Swarm, we need to download and build Geth and Swarm from source code. To do this, we need to have Git and Go installed in our environment. You can do this easily using the command brew install go git. Then you need to make sure your Go environment is set up correctly. You can do this by creating a folder called Go in your home folder and then exporting an environment variable called Go path, which points to this folder. We'll then install from source by downloading the Go Ethereum source code from their GitHub. Next, pile Geth and Swarm from source. We're in a folder to your path for convenience. If you run Swarm version, we can see that we are on do this report. To run Swarm, we first need to make sure we have Geth running. Then, in a separate tab, we run Swarm and point it to our Ethereum account using the BZZ account option and pasting in our public address. It will prompt for your password to unlock the key file for Swarm and then start up a local Swarm node on port 8500. Now we can easily upload files using Swarm command line tools by simply calling swarm up followed by the path of the file you want to upload. Swarm doesn't support encryption yet, so make sure you don't upload any sensitive data. After uploading, you'll get a unique hash printed out for this file that points to it on the Swarm network. Let's upload our index.html from our previous Blockchain Explorer example. To view this HTML file, we can navigate to our local Swarm node in the browser by going to localhost port 8500/BZZ, followed by the hash of the file. You can see the headers of our table appear, but not any data. This is because our Ethers app needs to run inside an ethers.io environment to function properly. We can quickly spin up a local ethers.io server using the ethers build serve command. Remember that our ethers.io container can point to any app URL. So let's point it to our HTML page by passing our local Swarm node URL with the hash. And this will render our Blockchain Explorer dApp hosted on decentralized storage. Awesome. Now let's see how we can do something similar using IPFS. The easiest way to install the Go implementation of IPFS is by using the installer from the IPFS website. If you navigate to ipfs.io in your favorite browser and go to the install binary somewhere in PFS repo for which will still print of links to other contents of LS, but now we're going to upload the directory to upload and make sure we can invoking 80 use our local or appfs or
40 minutes.
Thank you for joining.
An Achilles heel for centralized cloud solutions and a
It's all a quick one, right? Ain't got no 40 minutes for this shit.
Core of Web3 is built on the blockchain, but the blockchain can't store most of the information on the web. In fact, storing anything beyond basic transaction information on the blockchain is both slow and prohibitively expensive. To address this problem, Web3 needs to decentralize storage and connect that storage to the blockchain. Now, we already have a system that works peer-to-peer file sharing. If you were around in the 1990s and early 2000s, you may remember peer-to-peer technology being used to share music and video files. And this technology eventually evolved into BitTorrent, which is decentralized storage in all but name. I share a file on the network, someone else downloads that file and also shares it, then other people download and share the file, and soon the file persists in the decentralized network, even if I turn my computer off. Decentralized web storage is a further evolution of this idea, and IPFS, the interplanetary file system, is one of the most built out and operational versions of this idea. Here's how IPFS works. When a file is stored in IPFS, it's packaged in IPFS objects, each containing 256 kilobytes of data. If the stored file is bigger than 256K, which most files are, several objects are created, including an index object explaining how to put all these objects back together to create the file. Each object is given an encrypted hash describing the file, which serves both as the address for the object and as proof the object has not been tampered or altered with. These objects are placed on the network and duplicated by any IPFS node, so any computer or server running IPFS that accepts new objects. To retrieve a file from IPFS, you send a request with a hash address to the index object of the network, and the matching IPFS objects are returned to you from whichever nodes are closest to you. But this is a bit of a problem. When a file is changed, the file hash changes with it. So that means if a file is updated, the address to that file changes as well. This doesn't work all that well for things that can update, like applications or websites. To solve this problem, you can set up a mutable pointer, a lateral link to something that can be changed over time. So whenever a new version of a file is added to the network and a new set of file objects are created with hashes, the pointer redirects the points at the new version while leaving the old versions on the network as well. This means even though you update a file, the original file will remain on the network and be retrievable, which gives us historical permanence. So how does the blockchain fit into all of this? Well, by adding domain names to the blockchain through services like ENS, the Ethereum name system. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address to that file to your ENS domain NFT. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file storage and retrieval is fundamentally different from how the web currently operates. This also file on IPFS. Blockchain domains are NFTs with permanence. So added to the network, like applications or websites. To solve this problem, you can set up a mutable pointer, a lateral link to something that can be changed over time. So whenever a new version of a file is added to the network and a new set of file objects are created with hashes, the pointer redirects the points at the new version while leaving the old versions on the network as well. This means even though you update a file, the original file will remain on the network and be retrievable, which gives us historical permanence. So how does the blockchain fit into all of this? Well, by adding domain names to the blockchain through services like ENS, the Ethereum name system. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address to that file to your ENS domain NFT. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file storage and retrieval is fundamentally different from how the web currently operates. On the traditional web, the web we are currently working on right now, you request files from a specific address, a domain name mapped on the global DNS, the domain name system, to an IP address. That's what HTTP, the hypertext transfer protocol, does. Points at a physical location on the web from which we pull files. With ENS and IPFS, you request files by querying the blockchain for the address the ENS NFT points to. That request is sent to IPFS and the network returns to matching IPFS objects from wherever they are stored. And finally, your browser reassembles them into the files you requested. This process is a complete rewrite of how the web operates based on a whole new set of protocols and protocol interfaces for blockchain-based domain name services and for decentralized file retrieval. As I record these, only a couple of browsers, namely Brave and Opera, support ENS and IPFS out of the box, though you can also get extensions for many other browsers to add support. And there are now Web3 browsers coming online as well. Though you update a file, the original file will remain on the network and be retrievable, which gives us historical permanence. So how does the blockchain fit into all of this? Well, by adding domain names of the blockchain through services like ENS, the Ethereum name system. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address to that file to your ENS domain NFT. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file storage and retrieval is fundamentally different from how the web currently operates. On the traditional web, the web we are currently working on right now, you request files from a specific address, a domain name mapped on the global DNS, the domain name system, to an IP. Well, this means you can set up a mutable pointer, a lateral link to something that can be changed over time. So whenever a new version of a file is added to the network and a new set of file objects are created with hashes, the pointer redirects the points at the new version while leaving the old versions on the network as well. This means even though you update a file, there's historical permanence. So adding domain names.
Okay, first you have the mutable pointer, right? Which would occasionally be updated with the latest address, which points to the file that you're looking for, right? And this mutable pointer, okay. So Okay, so this multiple pointer is assigned to the NFT, and yeah, okay. And you can use and how to assign it to NFTs by putting the multiple pointer to ENS and
the blockchain through services like ENS. It set up a file name system. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address to that file to your ENS domain NFT. This also means
Okay, so from ENS you get the you get the domain NFT, right? Yeah. Okay, ENS you get domain NFT, and your NFT has the information of the multiple pointer. That's it.
anytime you need, you can map the address to that file to your ENS domain NFT. This also means
Okay, I think it's much simpler this way. So you got the multiple object. Okay, you got a multiple. Okay, you got a multiple pointer, which points to the actual file. Okay. When you say multiple mark,
anytime you need to change what the address to that file to your ENS domain NFT. This also file on IPFS. You can map the address to that file to your
Okay, so basically the multiple pointer is an address, which can be changed over time. Yeah, because it's a pointer. Okay, so anyways, you have a address pointer, and you put it into the NFT, and in this one it happens to be a ENS NFT, right? So you can use the ENS NFT to retrieve the pointer. Let's say the pointer is an address, right? So you put it as an ENS NFT. Okay. Yeah, okay. So you basically make an ENS NFT which okay. Yeah. Yeah. Got it. Yeah. So in HTTP, it's like you got an URL which is used to yeah. Okay. URL. Yeah. Okay. Not that hard. It's a bit hard to explain the whole concept clearly. Right? So you have a ENS NFT which stores the address, right? And this address is a mutable. It acts as a mutable pointer, and it always points to the latest version of the file. The thing is, I'm not very clear how the mapping happens, right? How does it always get to map with the latest version of the file?
ENS domain NFT. Traditional domain name mapped on the global DNS, the domain name system, to an IP address. On the traditional web, the web free-will to change what your domain points at, you need to update it on the blockchain. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file
update it on the blockchain. Okay. Yeah, because NFT, yeah, NFT. Yeah. You can actually change the value that it stores. Okay. This is a token, right? Token is also a smart contract. And it can store values. And you can update it on the blockchain. Yeah. Okay, cool. Mm. Yeah. One of the fundamental quality of decentralized blockchain is that data they hold is immutable. In other words, it cannot be changed. No one can amend the information associated with the code. And this is something called mutable NFT. So original use cases for NFTs such as collectibles rely on the immutability of NFT images and metadata to preserve rarity. The key element and blah blah blah. Yeah, okay. Don't care about that. However, many assets evolve over time, both in real life and in digital realms. So NFT is can change it. The game character has been my bar. They migrating to new contract. Expensive, slow, so kind of several ways to secret. Change over time. NFTs. That's something. So IPFS creates multiple links based on graphic hash of their data, based on the hashes. And this design is great for verifying. Yeah, fuck, it's already 11:53. Let's give it like 20 minutes more to the correct day. The design is great for verifying that your data is correct, but once you've shared the CID with the world, what happens if you need to fix the typo? So it's gonna be a problem, right? So naming services provide a way to map a consistent name to a changing address, right? Yeah. So this is what you call a mutable pointer, right? And that means you can point to content in IPFS that may change, right? It's perfect for pointing You're still not explaining what the fuck. So approach one is the NFT storage plus Web3 name, which is ENS in this case, I think. Okay. I have a feeling that I'm gonna read this several times. Already tired. But I get the concept. Okay. Getting retired. Let's call it a day. See ya.